Hello, and welcome to this video tutorial on how to configure dual stacking in an ISIS network. I'm going to show you how to configure IPv4 and IPv6 addresses in a simple ISIS topology. Dual stacking allows you to implement IPv6 alongside IPv4 in your existing networks. When you implement IPv6 this way, you can provide the same services over IPv6, for example video, voice, and high-quality data, that you currently provide in your IPv4 networks. You can then perform incremental upgrades and avoid service disruptions while migrating to IPv6. Unlike RIP and OSPF, ISIS does not require a distinct protocol or a new version to support IPv6. Let's take a look at the topology. As you can see, the topology includes 3 routing devices in a single ISIS area. R1 has point-to-point connections to R2 and R3. The first step is to assign addresses to the interfaces. On R1, let's add the interface to R2. First, we configure an IPv4 address. Then we need to configure an IPv6 address. To automatically generate the host number portion of the interface address, I am using EUI64. This is optional. And because this is an ISIS network, we also need to include the ISO address family on the interface. To save time, I have already configured the interface to R3. To configure the loopback interface, we need to set 3 addresses: an IPv4 address, an IPv6 address, and an address for ISO. Okay, now that our interfaces are up, we need a routing protocol for remote communication. So let's enable ISIS on the interfaces. For ISIS, this step is the same whether you are using IPv4, IPv6, or both, as in this example. You do not need to use the passive statement on the loopback interface. In ISIS, the loopback interface is always passive. Always remember to commit your configuration if you want to see results. I have already configured device 2, as shown here. Likewise, I have already configured device R3, as shown here. To verify the configuration, I'll enter the show ISIS adjacency detail command. As expected, the output shows that the 2 neighbors speak both IPv4 and IPv6. Our next step is to ping the remote IPv6 interfaces. If you recall, we used EUI64 to automatically assign the host portion of the IPv6 addresses. This means we will need to do some network discovery to determine what addresses to ping. So let's move over to device R3 and run the show interfaces terse command. The pingable IPv6 addresses are the 2 that begin with 2001. Now let's go over to device R2 and ping R3's interfaces. Eureka! It works! This means that ISIS has learned the IPv6 routes. As one final step, let's take a look at R1's IPv6 routing table. Notice that the output shows the IPv6 direct and local routes. The output also shows the IPv6 routes that were learned through ISIS. Thank you for taking the time to watch this video.